Hello, today is November 25th. Today, given the reactants of a double displacement reaction, you're going to write the word equation, balance the chemical equation, and write the net ionic equation. You're going to need to have the following: your pencil, notes, a periodic table, and your solubility table. You will need these items in order to view the introductory video and take notes, because you will definitely need these notes to do your net ionic equations worksheet, which you're going to be doing today with your table partner. Don't forget your vocabulary is due December 3rd. Let's pause the video for a minute, allow everybody to get the materials out that they will need in order to be successful while taking their introductory video notes. Okay, double displacement reactions are reactions that have two compounds reacting together. When they do, the positive ion is going to attract to the negative ion, or the anion, on the other compound. And then the positive will attract to the other negative. What will happen in this case is the sodium will form with the nitrate and the silver with the iodide, so that you get the following: sodium nitrate plus silver iodide, just like during your double displacement reaction lab. To write the balanced chemical equation, you'll need to remind yourself, what does sodium, iodide, silver, and nitrate ions look like? And these are the ions from your periodic table. Sodium iodide and silver nitrate would be NaI and AgNO3. No cross down, because the ion charges are the exact opposites of each other and will cancel out and form a neutral compound. You will get this as a result. Now, from your solubility table, don't forget to look up to see which ones are aqueous and which ones are insoluble, such as silver iodide, and therefore will form a solid. And we'll go ahead and finish putting those in. The net ionic equation. All of the compounds that are aqueous or aqueous are soluble in solution. And since they're ionic compounds, they're going to break up into their different ions. So I'm going to get an Na ion and an iodine ion. That's going to break up and form sodium ion and an iodide ion. Same thing is going to happen to the silver nitrate and the sodium nitrate. The silver iodide will stay together because it is a solid. When you're done, it will look like the following. Notice how we've broken up the ions and placed the charges of the ions up into the air. We've also put down the symbols. AQ for all of them that broke up, and then solid for the one that stays together. The net ionic equation is going to be all those ions that have changed their form or have had the spectator ions removed. Since sodium was an ion here and here, it is going to get removed. It is a spectator ion. Since nitrate is the same here and here, it is going to be removed. It is an ion. What you have left is the iodide, iodine, and the silver ions forming silver iodide. So our net ionic equation will be the following. This is a reaction actually taking place. Your spectator ions are the following. Notice the spectators are not written as a balanced chemical equation. They're just listed as independent ions because they're not actually taking part in the balanced chemical equation at all. Let's try another example. Example number 2. Potassium carbonate plus barium nitrate. Once again, we want to put the positive and the negatives to switch partners. So you always end up with a positive and a negative together so that they can cancel each other out. So I'm going to get potassium nitrate and barium carbonate. Now, which one I want to list first, it doesn't really matter. If I want to say potassium nitrate plus barium carbonate, that's fine. If I want to say barium carbonate plus potassium nitrate, that's okay. as long as they're on the right, and as long as they are going to be products. Next, we want to take a look at the solubility table. See which ones are soluble and which ones are not soluble. As it turns out, we're going to have 3 that are soluble and therefore will be aqueous solutions. The barium carbonate is not going to be soluble, and as a result, I am going to give them an S down here for solid. For writing down the balanced chemical equation, I'm just going to bring down these names, but I'm going to write them in the formula notation. So I need to remind myself, what is potassium, what is nitrate, what is barium, what is carbonate? And I have them written above from the periodic table. When I put them together, I will need to, in the case of potassium carbonate, to cross down the charges, because a +1 and a -2 do not balance each other. I will do the same thing for barium nitrate, because a +2 and a -1 do not cancel each other out. Now that this is written, it is not a balanced chemical equation. I'll need to go in and to balance it. And when I'm done, there'll be a 2 in front of the potassium nitrate. That way I'll have 2 potassiums and 2 potassiums, 2 nitrates and 2 nitrates, just as before. Let's go in now and take our ions and separate them for all the things that are aqueous solutions or soluble in solution. Solid there. And AQ. So I'm going to break up everything but the barium carbonate. Notice how the charges here match up with what the charges were on the periodic table. +1 for potassium, +1 for potassium, -2 for carbonate, -2 for carbonate, and so on. To find my net ionic equation, I want to eliminate all the spectators. Anything that's the same on both sides. So there's potassium here, there's potassium here. They're spectators, they're exactly the same, they cancel. The carbonate does not cancel, because here he's a carbonate ion by himself, but here he's bonded with the barium. Barium is not a spectator for the same reason. Here he is an ion by himself, and over here he's a part of the compound. The nitrate, though, is an ion here and here. He cancels. That leaves me with the following 2 ions and solid to form my net ionic equation. And then finally my spectators will be the potassium and the nitrate ions, once again with their ion charges listed.